Example number 3, x squared minus 7x equals 0. Okay, so again, think about those list of steps. Is it in standard form? Which it is because it's equal to 0. So that means factor the polynomial that you have on the left side. So I have a binomial, x squared minus 7x. Okay, first thing, go back to your list of rules for factoring. I have to look for a greatest common factor. Okay, so is there a greatest common factor? X. So they both have an x. I can take out an x, which x into x squared would be x. X into negative 7x would be negative 7 equals 0. Okay, so now that's factored. I can't go any further with it other than just taking out the GCF. Okay, now my next step is to set each factor equal to 0. Well, if your greatest common factor contains a variable, you have to include that and set it equal to 0 also. So I set x equal to 0, and that's one of my solutions. And then x minus 7 equal to 0. Add 7, so x would equal positive 7. So my two solutions would be 0 and 7. Okay, so if your greatest common factor includes a variable, you have to include that in your solution set. Okay, example 4, x squared equals 25 is not in standard form, so I would want to subtract 25 to get this equal to 0. Okay, so now I have it in standard form. Factor. There's not a common factor, but this is actually the difference of two squares. So I can break that down. The square root of x would be x squared would be x. The square root of 25 would be 5. And then remember, one would have to be a positive, one has to be a negative. Now I have it factored. Set each binomial or each factor equal to 0. And then solve. So x plus 5 equals 0. If I subtract 5, would give me x equals negative 5. X minus 5 equals 0. If I add 5 to move it over, I would have x equals positive 5. So my two solutions would be negative 5 and positive 5. You may see the braces around these as a solution set, or they may just have you type it in with a comma between. Okay, example 5, x times x minus 4 equals 21. Okay, this is not in standard form, so if I do not see this equal to 0, I know I need to clean up the left side. Okay, so I would distribute this x. X times x is x squared, x times 4 is negative 4x, and in the same step, I'm going to subtract 21 so that I get all of this kind of condensed into one polynomial equal to 0. Okay, so now I can factor. There's not a common factor. 1 times negative 21 would be negative 21. Make my list. What's going to subtract to be negative 4 would be a positive 3x and a negative 7x. Divide both of these by the first term, divide by x squared, reduce, so that's going to be 3 over x and negative 7 over x. So my two binomials would be x plus 3 times x minus 7 equals 0. So now it's factored. Set each factor equal to 0. And then solve. So subtract 3 here would be x equals negative 3. Add 7, so x equals positive 7. So my two solutions would be negative 3 and 7. Okay, number 6, example 6, this is probably one of the easiest ones. Okay, as I look at it, I would say, is it in standard form? Well, not exactly, but it is equal to 0. Okay, I could multiply this back together, but then I would only have to factor it again. If it's equal to 0 and you already have a product of two binomials, it means that this has already been factored. Okay, so we're already down to the third step, where we just take each one of these factors, each one of the binomials, and set them equal to 0. So x plus 5 equals 0, 2x plus 3 equals 0. Solve each one, so subtract 5 would give me x equals -5 as one solution. Solve the second equation would be first subtract 3, so that gives me 2x equals -3. Divide by 2, so x would equal to -3 halves. And so those would be my two solutions, -5 and -3 halves. So we didn't even have to factor on this problem, okay?